So just in case you didn't get it fully from the text, it's kind of hard to see in text. I'll explain it over here. So this equation, it's already set to 0, which is generally what we do anyways, right? If you have an equation with things on both sides, we usually move it to one side and set it to 0, because that way we can factor, right? So how do we make this whole equation equal 0? Well, there's two parts to this equation. It's already factored, right? If we can somehow make this portion be 0, then it doesn't matter what this is, because when you multiply it by it, you get 0. Same with this portion. If we can somehow get this whole bracket to be 0, then the whole thing cancels out to be 0. So in case 1, we have to somehow get sine theta to equal 0 to make this statement true. So, just like any equation that you're doing, you're not just saying that this by itself equals 0. You have to include everything that's with it. You're saying that whatever you plug into here, when you put sine 2 of that number, then you get 0. So, when would sine theta by itself equal 0? Like you said before, that's at your values of 0, pi, and 2 pi. Because if you look at the unit circle, right at 0 here, your y-coordinate is your sine value, it's at 0. Over here, this also satisfies the equation, right at pi, it's 0, and back here is 2 pi. So, this doesn't prove to you that this is the answer. This proves that sine theta is 0, but it doesn't show that sine 2 theta is 0. The way to actually get these values is you have to show that when you plug in certain values into here, sine 2 theta would equal 0. So, somehow, whatever we plug into here, we need to land back on these three values, or something that gets to 0, right? So, what can we multiply? So some number times 2 equals 0. And that answer is 0. This is why 0 is a valid answer. Not because here, because of this. Because 0 times 2 gets you a value where sine theta would equal 0. Okay, for the second one, a certain number times 2 must equal pi, because we know that pi will get it to 0. So what number times 2 will get you pi? Pi over 2. That's why this is a valid answer. For the third one, a certain number times 2 is 2 pi. And that number is pi. And again, that's why pi is a valid answer. Not because it's up here, but because when you double it, you get 2 pi. So that, why are these valid answers as well? Because initially, it said anything between 0 and 2 pi. Right? But still, pi isn't a valid answer itself because it's here. It's because when you double pi, you get 2 pi, which lands you at 0. And 2 pi is actually a valid answer because when you multiply by 2, right here, you get 4 pi, which basically goes back around and lands you at 0. That's why 2 pi is an answer. That is why this is true. And so how do we get the last one now? Well, this value, 3 pi over 2, if you were to double that, you're making another quarter loop around, you're landing back at pi. So this one, pi over 2, is half of pi. 3 pi over 2 also works because you're coming back around and getting back to pi. So, 3 pi over 2 is another answer. And again, not because it equals 0, because it obviously doesn't. Because when you double it, you're landing back on 0. That's why.